about standard form. Standard form is the third and final form of an equation of a line that we can use to graph. There is some important things that we need to know. For example, we have, instead of y equals mx plus b, or y minus y1 equals m times x minus x1, this one looks to me the most different, as this form is ax plus by equals c. Ax plus by equals c. Now, there's lots of rules for standard form that we need to go over. For standard form, the biggest thing is that a, b, and c have to be integers. That is, those whole numbers that are positive or negative. What I mean by that is it can't be fractions, it can't have decimals, it has to be integers. Integers, okay? The second rule, a cannot be negative. So a has to be positive. A cannot be negative. Okay. Our third rule for standard form is that a and b both cannot be 0. One or the other can be, but both of them cannot be 0. So we could have where a is 0 and b is a different integer and c is a different integer, but a and b cannot both be 0, because then that would be a false statement, because then we would have a different number for c, and 0, if a and b are 0, that'd be a times 0 plus, or I'm sorry, 0 times x, which was 0, plus 0 times y, which would be 0, equals a different integer, which would be a false statement, because 0 would have to be equal to 0. And I'll explain that here in a little bit, or we'll talk about non-examples. So, the fourth and final rule is that they can't have a greatest common factor, meaning they can't all be divisible by the same number. The greatest common factor has to be 1, the greatest common factor. So if any of these rules are not true or not met, there's going to be some additional work you'll have to do in order to make sure it is officially in standard form. Now, you might be wondering, why is this even a thing when we have easier forms that don't have so many rules? Well, the big thing about standard form is it's very easy to find our y-intercept, just like the other forms, but this one is also easy to find the x-intercept, or the 0 of the equation. Now, the y-intercept happens when the x value equals 0. The x-intercept, or the 0 of the equation, happens when the y value equals 0. And this should not sound very foreign to you, because we've been dealing with y-intercepts with the other forms. And the y-intercept we've talked about, we know has an x value of 0. We don't go left or right because it's on that y-axis on a graph. The x-intercept is kind of the same thing. Where does it cross the x-axis? If it's an x-intercept, where does it cross the x-axis? And that would not be going up or down any as far as our y. So our y value would be 0. But the standard form, it's very easy to find these 2 points. And when we graph an equation, we either need a point and a slope or 2 points. And so the other 2 forms give us point and slope, whereas this form gives us 2 points. So those are just kind of the differences you might see. But I want to give you some examples and non-examples. So an example and non-example. All right, I just made a division sign. Non-example. Okay. So an example would be something like 7x minus 9y equals 14. A, B, and C are all integers. A is not negative. A and B are not 0. And neither of those numbers can be divided by anything other than 1. So, all right, the greatest common factor is 1. 7 and 14 could both be divided by 7, but because 9 cannot be divided by 7, then that makes it 7 not a greatest common factor. Some non-examples. If I said 3x plus 6y equals 12, all of those A, B, and C all could be divided by 3. That is not standard form. Another non-example, negative 4x plus 5y equals 22. One example, I want to show you what I mean by A or B can be 0. If I had 16y equals I'm going to say 9. Yeah. A is 0 on that one. That is not negative. It still meets our rule. And A and B are both not 0. So where A is 0, then that's okay, as long as B is not 0 at the same time. Another example, if I had 5x plus 12.5y equals 32. Because we have a decimal, B is not an integer, so that would not be an example over there. So that's kind of an idea of what standard form is. And I want to quickly go over the first, I'm going to just add another page of how to, in standard form, how to find the x and y intercept. And that is what makes this problem, or the standard form, so easy for us to graph. So if I have 3x plus 4y equals 13, I want to find the 0, or the x-intercept, and the y-intercept, or the points at those. So how I would find the x-intercept, just like we said over here, where the x-intercept, our y value equals 0. So to find the x-intercept, we would say y equals 0. So substitute in 0 for y. 3x plus 4 times 0 equals 13. So 4 times 0 is 0, so 3x equals 13. I'm going to divide by 3 on both sides. So x equals 13 thirds. So my y-intercept, my point for that, would be 13 thirds, 0. You can also convert that into a decimal, but I am not going to take the time right now to do that. So for our y-intercept, our x value equals 0. So I'm going to do the same thing here, and I'm going to say 3 times 0 plus 4y equals 13. 3 times 0 is 0, so 4y equals 13. I'm going to divide 4 on both sides. y equals 13/4. So my ordered pair for my y-intercept would be 0, 13/4. And sometimes the numbers will come out prettier, but that is how you can find the two intercepts, and then you can actually plot those 2 points and draw a line to connect it, and that is how you graph using standard form.